Hello boys and girls, this is a response video to a video uploaded by George Hotz entitled Thermodynamics is to energy as question mark is to intelligence. So in this video, George laments the circumstance that there does not seem to be a theory of intelligence that is quantitative in the sense that you take some problem and then you could compute or predict or estimate a number which represents the amount of intelligence that is required to solve this sort of problem. So that's one way to summarize it. He gives the example of how much intelligence does it need to solve Fermat's last theorem, the pi 1 arithmetic statement that was resolved 20 years ago or so, but this was a long-standing mathematical issue that is now a theorem, but like a hard question. And then the question is, can we quantify how much that intelligence is needed? Is there such a thing? And interestingly, in the video, IQ does not come up, the sort of IQ that is used to with humans. Sadly, I assume he has some counter case why this is not the way one should go down to estimate intelligence, especially in the context of machine learning and AI, which is I think where this all comes from. So I would like to hear the counterpoint why these methods do not apply, right? Because in general, I think the insight is that if people are capable, then their capacities to solve different sorts of problems correlate with another. Somebody who's good at this is also good at that, and that's I think what the argument why IQ might be a valid measure, and then why not use that also for machines, for example, right? But maybe that's some good counter case, or maybe that is not sharp enough. He gives an example of a quantitative theory. It talks about a thermodynamical example where he says, the question of getting from water, so much water at this temperature to a higher temperature, I think he talks about a gallon of water from 0 Celsius to 100 Celsius or whatever the numbers might be, and then he does some back of the envelope calculation that you see here, where he says, how much wood would I actually need in grams if I burn it to heat up the water? And he demonstrates he can get to some answer with some physical theory, and he has some conversation with ChatGPT, which roughly gives him the same answer, and so he emphasizes, there is a sharp answer, but this does not seem to be the case with intelligence in any hard sense. I mean, also the theory applied to humans, which is not mentioned in the video, is also probably not as hard. So regardless, I after saying a few words on how I actually know of George Hotz, I go through a few of the buzzwords he brings up and try to give some pointers in the fields where I know what I'm talking about, and also give some counter cases for why that might be hard or not even possible. Because I think the question generally is quite interesting. I mean, I have a few deep learning videos on my channel, maybe 1-2. I love thermodynamics, statistical mechanics, and computability theory. I mean, I also do. I would not say I love it, but I have to know it. And so that's the sort of question that I think is valuable. If you look back at in the past, if you look at people like, I don't know, Neumann or Ramsey, they also sort of boldly jumped into topics that were not hard sciences and try to come up with a theory. So I think that's valuable if people try to play around and philosophize and formalize I'm thinking of von Neumann because of certain game theory and economic theory, and similarly with Ramsey, who like both of these super smart people were like very broad, reaching out, making new subjects, and if there is the hope to like learn more about intelligence, and especially this is motivated by machine learning, AI safety, these sorts of topics. He basically complains and is actively asking for other people's takes. So that's one take in this video. Okay, so I know George Hotz because he some years ago put on a video on metamath, which is a theorem prover. Like it's an old theorem prover basically. Like it's not the type theory sort of theorem prover, but the nice thing about it is that it uses essentially normal math. By normal, I mean the sort of logic that is used in math departments, and maybe apart from how parameters are treated in the first order logic. But the nice thing about that project or the website also is that people can make their own math boxes, is what they're called, and can postulate their axioms and then use the prover to validate whatever super formal proof they give. And because of that, you find proofs of certain things there, which are fully formal, but you literally do not find anywhere else on the internet. So somebody already did the work for you if you have interest in certain subjects. And in particular, in my case, there was once, or he's still a guy who proved a bunch of set theory basics, induction and so on, from a predicative separation constructively. And that was really nice to see, like the proof. It's not readable, and the project is sort of ill-designed from today's standards, I would say, but it's nonetheless pretty cool. And in any case, so George Hotz, his background is that he's famous for being like a hacker, like opening some proprietary systems, is this my understanding anyway. And he has a fantastic stamina in jumping into some subjects and trying to, like, without having any idea about metamath, making like this 6-hour video trying to understand and do things with it. So that's admirable there. And also he started AI related companies. One has to do with SLAM in computer vision, which is exactly what I do as a job. And yeah, I mean, I'm not a machine learning expert. I mean, I know how to code up a deep neural network and solve some, NIST problems and these kind of things. And I know the universal approximation theorem, these kind of things. But I'm a physics PhD with a strong interest of thermodynamics, foundations, statistical physics. So this is sort of my topic, and that's why I'm interested in that. Okay, so I have here sort of my notes, so that I know what points to cover, or my criticisms or my pointers. I've already explained the first few things. There are some things, there's some, the video that he posted is like, I don't know, 70 minutes long or so. And he has this question, but he gets sidetracked with a bunch of other topics that are probably, they don't help the video. There's a few things that I don't really want to, there's not the point of this video, but I just want to mention, so that in the next like 5 minutes, I'm going to say a few little things about certain points that are brought up, but they are not about really developing this theory that he's looking for. So the first thing there, when discussing quantifying the capacity of people, manpower comes up, sort of, compute, brain power, and all these things, and horsepower. And I like the way he talks about it makes it seem like horsepower is like the strength of a horse, like in some very quantified objective way, as if it was really relating to a horse. But I'm not sure if that's the case. I I might be wrong about that, but I think that to have heard that it's not really horse, like it's horse related, but it's not like literally that, like it doesn't really quantify a horse in that sense, I think. But I mean, look that up, George. If you bring it up in future arguments, probably you can make a humorous history sidetrack. But I don't think like, I don't think that it is like what, like some measured variable, what or number what a horse can pull or something like that. I think it's a little bit more complicated than that. In any case, then there's a rant about truth and God and all these things, and I sympathize with some points. I think if everybody in the world would die, everybody dies from a virus except me, and I'm not super depressed in that hypothetical scenario, let's say, then I would probably still want to read math books and stuff like that, or physics books. But I don't think this sort of curiosity, right, extreme curiosity or whatever, needs this philosophical commitment to truth, right? I don't think that there has to be any truth. And to be honest, I sort of doubt it. That I think a lot of the problems we have are language, game issues. Like, I don't want to go all Wittgenstein on you, but I found this truth talk a little questionable, and it probably doesn't help anything. But I mean, if it makes you feel good, okay. And then there is this whole like especially in the second half, there's this sort of side track rant. I don't know really the background. Maybe this is just a side comment, or maybe it's more related to the intelligence problem. I think it seems to be related to the AI alignment problem, but I think he makes a point and agrees that this depressed AI doomer guy from the Rational something website, I forgot his name, EY somehow. In any case, that this guy says that university got sidetracked, or they worked on the wrong problems, and so we didn't go further with solving the AI problem. And there's like, I don't know. I'm not sure if I mean, it might be that the AI alignment problem had been formulated in the past, and they didn't go as far as we might hope. But not being able to solve a problem is not, it's not enough to criticize the university for that. Like, there's a few things like ill with that. Like, maybe the problem is just hard, right? It seems to be very hard, and so maybe that's the reason why they didn't get there. And we shouldn't conclude from that the universities are like sort of ill-guided or go down the wrong paths just because they didn't manage to solve the problem already, right? So looking back, we see that they didn't do it, but I don't know why there's this negativity about the universities. And then there's another point. I really do not want to really go too deep into that, but there's also this underlying presumption in these whole arguments that the universities have to serve the people from, I think like it's probably a problem with the fact that there's just one word, university, but the concept has like shifted so much in the last 300 years. But I think a university should be a place that a state affords, and where the people who go to university benefit, and not as job education necessarily, but like for themselves. But the way this is framed here in this complaint, and I think this is general, in particular like in the US probably, it is framed as if the the university were some institution that the government pays to do long-term research or something, and it has to have an output, which is like, I think it's a bad view of what a university is. I think university should be, I mean, obviously university costs money and so on and so forth. It's not for free, and maybe my viewpoint is elitist, but I think a university should benefit the people who go there, who intellectual curiosity and all these things, right? It's not like a fabrik, it's not like what is the word? Where some factory where you get something out of it. I think this is like an ill-guided viewpoint from the start. I mean, you could have the sort of idealized university that I speak of for people who go there, and at the same time have another sort of institution where that is like state funded and where people produce something and which has like a job education component. But if you just treat university as just continued job education, then you don't have this other nice institution where people go to learn, right? And again, this is like a difficult subject, of course. It's tied in with economics. How much can the state afford and blah blah blah. But okay, this is just a side comment here. Then there's this, I think this overly optimistic praise of ChatGPT, which I really cannot subscribe to there. I mean, obviously this is great, like ChatGPT is great, but in the video Hotz describes it as this great learning tool, and I think it's really not it. Especially for math, and I suppose also for science, you get so much bullshit out of it, right? So I have some tabs open, and you could argue that probably that will go away if you have more capacity, train more, blah blah blah. I mean, I hope so, but we'll see if that's really the case. So just as one example, right? So just because that happened to me yesterday, somebody in some Discord asked about, you have octonions, which is like basically the higher dimensional version of quaternions, which are the higher dimensional version of complex numbers, which are the higher dimensional version of real numbers, and so on and so forth. And this guy was asking, what is the dimension of the special linear group where the elements are quaternions? Right? It's some abstract mathematical question. Just to like illustrate what the point is, like you have these special particular matrices, like rotation, for example, and if the 3x3 rotation matrix has 9 components, but really is determined by 3 real numbers, which are the angles. And so in this case, like if in rotation in 3 dimensions, you would have 3 angles around which you can rotate things. I have several videos on my channel on this topic. And in 2 dimensions, right, you go 1 dimension down. How many angles are there? Well, there's just 1, right? So for 3, you have 3, for 2, you have 1, and so on and so forth. And so there's this general rule. So for example, for in n dimension, the dimension of parameters that determine the rotation, like, if you want to know the 5-dimensional rotation, then you would have to have 10 angles which parameterize, and if you go up to 6, then you would have 15, something like that. And so this guy was not talking about the real numbers, but about like a much bigger structure, the octonions, and so this sort of falls out of this classification, right? Here you see a bunch of groups, they have all a bunch of dimensions there, and this is exactly the sort of question where ChatGPT is like really bad, and I expect the future AIs in the next 2 years also going to be bad about it, because like this person had this question, like making up this question, and it's not like there's much literature about this subject, right? It doesn't even conceptually work out, but there are so many examples where you have some object and it has some certain dimension and it's some small formula there, right? And what ChatGPT then inevitably always does is like it just invents formulas, right? or it invents book titles and these kind of things. And so maybe you can, like, with some effort, train the AI to be more cautious and say, I don't know, and that's why I'm going to engage with you. But in any case, that's not what the AI systems at the moment may do, right? If they don't know the answer, they predict the next word, and then they write down some formula, and then you ask, where does this formula come from? Give me a reference, and then they make up a reference. And like on math discords and physics discords, maybe also, like, people really hate this ChatGPT stuff. And maybe if you don't know the subject, then there's this, what's the Gell-Mann effect, where you read something and you think, oh, that's great, but if you know the subject and you know it's bullshit. I think this is here, like, so clear that I do not at all think that it's at the moment good for learning. Like, you can fish for words with these tools, right? You have an idea, oh, there's this something related to that. You type it in and you hope it mentions the other word where it has to do with it, and then you know it. But I would say at the math problems where I sometimes typed it in, if you ask anything which is not often repeated on the internet, like literally several times the same answers repeated on the internet, then if it's not that case, like apart from these cases, I think basically 100% of the time GPT is like just says bullshit. Like, okay, so this is my rant on that little subject there. So I'm not, and I don't quite understand why people are so, like, I know it's amazing that it works at all, but it does not really work, right? I don't know, maybe I'm too pessimistic, and maybe it will work in 3 years, but let's see. And okay, then he goes on a like libertarian reason. Like, I don't think, I mean, maybe most of the audience is Americans, but I don't think this helps the videos if you go into like local politics, or even if it's continental politics in this case. So far so good. Okay, so we're already 20 minutes in, but now we're sort of getting to the meat, right? Oh, sorry for going on these tangents, but maybe it helps you. So there's one point where the question comes up to like classify physical theories, and I'm not sure if I misunderstood it, but there's this sort of the question if thermodynamics is a classical theory. If that was really the question, I can say some words about it. If not, then maybe I just like it was just too incoherent. But probably I don't know if there's like a hard classification of what is classical, but in general, I would say classical stops where quantum mechanics begins by this classification, and I think this is a conventionally often used one. But this classification, also general relativity, would be classical physics, and you sort of see it to the extent that with quantum mechanics, all the Hilbert space mathematics and functional analysis really starts to matter. I mean, obviously you can also use a lot of functional analysis for everything that has to do with Lagrangians, and in this way you can also use it for general relativity. You can certainly use it for electrodynamics. So the math is not restrained to just quantum mechanics, but this is sort of the topic where a lot of these tools were even developed for it, right? A lot of group theory was developed for quantum mechanics. And so I would say quantum mechanics is sort of the where I would part classical from new physics. And quantum mechanics, like if you want a definition of where's the line, I would probably say that then quantum mechanics is when the situation where you don't assign to all definable observables as well a prediction of measurement value, right? Not at once anyway. So where you have the situations, like, roughly speaking, if you do a different order of measurements, then you can expect that the measurements interfere with each other. In any case, the theory does not say at the moment this and this and this and this is the things you will measure, because depending on what you measure, the other observables are affected. So this is where this feature comes in, this measurement jumping feature. Then that's quantum mechanics, and that's where classical mechanics ends, I would say. And more on quantum mechanics in a second. But now to the first real point that is, the video is called Thermodynamics is to energy as question mark is to intelligence, right? So the title says he wants to find a theory where these roles, like the theory of thermodynamics to energy is this new theory, this quantitative theory where you can, like with the energy from burning the wood, get a quantity, and this relates to the energy. And so for like now comes the part where I think you can get something more out of this video, really. Like I think this is like generally a bad comparison from the start. It doesn't really work. Well, the reason is that thermodynamics has no time variable, and as we will see, we will need a time variable to quantify this effectiveness of intelligence, right? So I mean, you can again skim through the laws of thermodynamics. They are about energy, they are about entropy and all these kind of things, but it's not about time. And obviously time plays a role if you want to like compute conductivity and diffusion, and if you want to talk about the power. It's also funny that this word does not really pop up in the video. He then talks about watts, the unit, but it sticks to the energy analogy. Power is not even really mentioned by explicitly. If you have a mechanical theory and combine that then with thermodynamics, and you discuss the capacity of this and that machinery to do this and this work, then you can talk about it per time, and then you have this time aspect there. But in thermodynamics itself, you find equilibrium, like you assume you have the equilibrium situations, and then you find which states can go into each other, and so on and so forth, and how these global state potentials and energy and entropy and so on will develop, and then you reason about closed and open systems and so on and so forth. But without time, you will not find a proper, like, you will not pin down this analogy if you just look at thermodynamics. And so why is time so important? Well, because clearly, the question is how much intelligence do I need to solve a mass theorem, right? And okay, let's say we have such a theory that quantifies that. Then it would seem that Wiles, who actually proved the theorem in the 90s, we have to assign him some value, right? He has apparently intelligence, and he has enough intelligence to prove that. So he reached this sort of bound, right? But clearly, solving this sort of problem depends on how much effort you put into that, right? Or maybe you want to say, if I give this entity a month, can it solve the thing or not, right? This variable, the time bound or time variable plays a role. Otherwise you can say, monkeys have enough intelligence to solve the problem because eventually they will evolve into humans, and the humans will solve the problem, right? You have to restrict the situation somehow, right? And this also brings us then back to the intelligence tests. I think I even have one opened here. These sort of tests where you have to find some sort of best answer, some pattern matching. These are time bound, right? You cannot sit there for 2 weeks and learn math and then solve this problem. If you want to quantify cognitively smart the person is, right? So it would seem that it has to do something with developing the like being able to solve a problem in certain time bounds would be like one like narrowing it down how we might get onto a computable number for intelligence there, right? And so thermodynamics, if you look at the theory, that just does not that doesn't go together, right? Now, thermodynamics is nice because it's about energy, and energy is this sort of additive quantity that is like in all of the physical systems. You end up assigning these sort of numbers, right? So I understand why energy comes up, right? This is like a constant in physics theories, right? But there seems to be a little bit of a problem. Now, of course, if you mix mechanics into the situation, then you have some laws of motion, then you have time dependencies, and then you can talk about diffusion and these sort of things, right? So just for an example, I have open here this Fick's law of diffusion, and because it has here a little bit of a history section, and similarly, you can talk about how things spread through the air, through a metal, and so on and so forth. So that once the mechanics comes in, then you have some sort of maybe a physical analogy there. If you apply statistics to mechanical systems, then as we then know since Gibbs and Boltzmann and so on and so forth, you can justify the thermodynamical theory, and then on the mathematical side, that ties into all these theorems like ergodicity theory and ergodic theorems, which sort of integrate out time aspects or tell you how certain time things don't matter, and then it just so happens that you can end up with this timeless thermodynamic theory, which just is about transitions of systems and legal configurations, right? So one thing to consider, so how to resolve that there. In the middle of the video, he then goes into like mentioning complexity theory and information theory, and I've also done some comments on that. Yeah. So one thing, like just a one note for thermodynamics, right? In thermodynamics, in quantum mechanics, you end up then having the Schrödinger equation, where if you choose the units of the Planck constant 1, like if this is just a constant, then the sort of inside of that theory is then that energy is basically replaced by sums of frequencies, like roughly speaking, so to speak. If you say you have the energy operator, the Hamiltonian, and you diagonalize it in spaces where this is possible, then it's just a list of frequencies, really. And in this way, energy is sort of out of the picture, and you're just talking about frequencies and how to have the composition of a system, like decomposition of a system to certain subsystems, certain frequencies, and it already smells like Fourier transforms. And then energy suddenly again relates actually to time in this very strong sense, in the sense that energy is just 1 over time, but that's like a very particular mechanical theory, and it's also not necessary to talk about thermodynamics. And although they are in the end compatible in the sense that, again, if you take quantum mechanics and you do statistics, then you can also end up with laws and that just validate the thermodynamic theory, right? Okay, so this is a little bit of a vague comment, but just to pin down the different physical theories and how they relate to all these topics there. Okay, and then George dwells on compute and capacity to compute, and here I want to make the point: just the capacity to compute as number itself, this will not work, and also not just capacity to compute. amount of computing capacity per time, this does not really solve the intelligence, this problem, right? And so one thing that was not mentioned, but was sort of obvious in this topic is the notion of pattern and pattern recognition, right? And I want to give this one example, and that you can also use when talking about this subject, right? Because this is like something you can easily like mention and people understand, and it sort of elaborates what is this sort of capacity that people must bring to count as intelligent. So, if you have the task of summing up this sum here. This is 1 plus 20 plus 20 times 20 plus 20 times 20 times 20. So there is a bunch of additions, a bunch of multiplications. You can do it. You get a number. And then there is a similar task here. 1 plus 7 squared plus 7 cubed plus 7 to the power 4 and plus 7 to the power 5. And then you can also do that. And if you have more capacity, compute capacity, then you can do higher numbers. If you have more memory, then you can go further there. If you have a better GPU, then you can compute it faster. But the point is that, of course, here, this is like a simple pi 1 theorem that there is a nice formula for that, right? This is the geometric sum. And I've just taken the first slide that shows that. So if you have some number r, let's see a natural numbers for simplicity, and you sum n terms, right? Then this ends up being this expression, right? So in other words, if you take this sum and multiply it by 1 minus r, then everything cancels out and you're just left with 1 minus r to the power of n plus 1. And the nice thing is that this works for any r and for any n. So there's this formula. So if I give you a huge r and huge n, you don't actually have to do these powers and sum them up. I mean, not that would be so hard in this case, but there's actually like a shortcut, to some extent a shortcut, if you can divide easily, that gives you this closed form solution, right? And this is like a mathematical theorem. You can prove it very easily with like an induction argument. Is the formula preserved if you go from n to n plus 1? And then you get this sort of formula, right? And I think this is a good example to keep in mind when discussing the intelligence topic, because clearly the intelligence is not about just being able to compute this number, but the intelligence is actually about also not just using the formula, but it's actually finding the formula, right? This new task. And especially maybe not in such a well-defined mathematical problem, but for a general problem. The question is, can the agent that we want to ascribe an intelligence to find the formula, be smart about it, about computing it, in a Landian sense, like accelerate and enable oneself to compute all these things much better in the future by finding this out about this mathematical fact about piano arithmetic, finding this, and also not just finding it, but also, it's not like it doesn't count if we say write a program that says find for this problem, find an algorithm, do pattern matching. But the system to, I would say to go in the direction of being live must also unprompted come up with the idea of even searching for a pattern, right? Or at least spend some compute to recognize when something pops up, because here it happens to be a pattern, but there's obviously a lot of things in the world where there might be some hidden patterns, and we didn't even search for things. We didn't even know that this sort of concept is related to this sort of concept, therefore we have not recognized the pattern, or maybe we had only few instances. If you only see these two examples and whatever comes out, then there's just too few samples to abstract the pattern. And I mean, maybe you could code up a machine learning tool that is like aggressively always pattern searching, but I don't think that's what life is. The intelligent agent must also dedicate capacities intelligently, right? So this is sort of meta. It's not about computing. It's also not about brute forcing the pattern matching procedure. But it's also choosing when to do so, in a sense, right? So now, having said that, now I'm talking about more this general intelligences. But of course, it depends. Like it's a question to George, basically, how he wants to frame the question, how narrow he wants it. If you do we just want to find to ascribe an intelligence to a system which is sort of designed to solve certain mathematical problems? Like does it quantify math solver tools or something much more general, right? So this determines what we allow and what we don't allow. Like is it like if we build this this algorithm which aggressively searches for pattern, does that count, or is this cheating, right? Is this really intelligent, or did we put it into that? Okay, these sort of questions must be like more specified, I would say. So to connect that to the words that were mentioned in the video, this of course relates to compression in the sense that if you talk about, you have to find the pattern, then what we might ask, what is the pattern? And then I think a fair answer is, well, the pattern is the expression which is compact but encodes all these different cases, right? So here in the math example where we have abstracted everything away with these variables, a very abstract mathematical concept, this is sort of a pattern that once you have the idea of a form of mathematical system, then you can encode this formula like in a bunch of tech symbols there, and then you have captured all of these, not just these two, but literally infinitely many of these formulas, and you are able to compute it much faster. So there's compression in the sense that it finds this highly compressed bits that represent the problem, and it can use it, but the compression itself is not itself the intelligence or anything, right? This is not just the one aspect that relates to the pattern, and the pattern is like one ingredient that we might use for intelligence quantification. And of course, talk about pattern, but really this is also just what the intelligence test does, right? The task is here, find the matching ABCD like solution, and of course if you add infinitely many more like variables, then you can probably find a complicated reason why all of these go there, right? You can say, oh well, there's this 11-dimensional mathematical structure, and all these things represent this and this and this, and that's why B is this. But this is a too complicated answer. This is like sort of the overfitting situation. You there's one answer that many people get to because it's like the explanation for why that solution is the right should be chosen is like compact. It's like a small low complexity thing, and that's why that's how it relates to compression. But this is like just one technical aspect about the problem, and I think this phrase intelligence as compression was uttered, and this is like, this is just one aspect of it, right? Kolmogorov complexity is of course this keyword here when it comes to compression, right? I'm not sure. I guess this is a known thing, but one word worth mentioning here. Then once you have this compression for this once you have this formula, then you also have a way of computing it faster, and we have then found the problem of computing this sum. There's actually an algorithm which does it much faster, so we have also optimized things. So this also goes together with runtime, and in that way it's also related to computational complexity theory and classification of problems, like very closely related to that, to runtime questions, is also what kind of problems we are looking at. Like Fermat's theorem is very similar to this sum problem here. This is some statement quite low down in the arithmetic hierarchy, which encodes the which ranks, which stratifies all this sort of propositions that you can make, and the proposition you can phrase that as a task, and so this the task of the study of putting different problems into these different categories, and thereby quantifying in one sense how difficult they are, is also of course then highly related to the problem of assigning intelligence number, because if the problem is harder in some formal sense, then supposedly it might be more difficult to find the solution. I mean, this is I don't know if maybe there's some room for mathematical theory that really like gives you a quantification of how easy it is to get to a proof, like just if this problem is stated in this way, then it's actually harder to find the proof, and so on and so forth. But I think this is really what proof theory is about, and so maybe the phrasing is obscurant, but in a way I would like to defend a little bit the academic subjects there, although as I said, I really like the idea of branching off to a new theory and finding new terms, because often it is the case that if you make a new theory, define new primitives, then suddenly it's much easier to see the answers to these sort of things. Yeah, I mean, I've written down this, like when I talked about university, there's this thing, this is just a side comment again, but there's this sort of thing where like there's this sort of people, and I know this is not an offense or anything, but I guess George also falls in this category where like they feel very free of like dissing the academic subject choices and say, oh, this is really useless, or this goes in the wrong direction. But at the same time, they're like what I call like high school plus Wikipedia academics, right? So just to dump here on someone, like Vitalik Buterin, for example, right? I think he's a smart guy, but it's clear if you read some of the Wikipedia of his Twitter posts that he just likes to use the word like homomorphism and so on and so forth. But what he actually writes, like the guy should have just taken 2 years of math, like academia, and then it would have like there's no stupid questions, but there are kind of sometimes like stupid tweets, especially if they're like presented in this self-confident way, and you see this and so I will admit that there's also cases where I think the academic community should just work on something else, but in the end this is just my personal preference. And if you want to preserve a culture of research and a common language and enable people to build on other people's work, right? So the follow-up students to Wiles, or even Wiles in relation to his Grothendieck or whoever came before him. If you want to have this culture, then you have to have these clusters of interest, right? You cannot dismiss the research topic clusters. You cannot dissolve them without dissolving also the capacity of new students to learn in an effective way. I think if everybody has to be high school plus Wikipedia learner, and there's no problems being handed down, just whatever is fashionable or relevant for Silicon Valley. Then probably if the things were like that, we probably wouldn't have gone so far, right? I don't want to over defend the topic selection in universities, but I don't know. I think this is a little bit this short-sighted complaints. Okay, maybe I'm too much of an academic, despite not being in academia since 2015 or so. But okay, just an impression I got from the video. Yeah, and then there's of course the question, like, if we have a theory which assigns numbers to intelligences in that way, like again, do you want the theory restricted to these sort of mathematical problems and patterns that you can really specify, or do you also want something, the way you talk with your mom and your girlfriend? I imagine there is some other intelligence going on than this sort of pattern recognition. It might be wrong. Maybe we're just automaton and solving the one problem, solve all of them. But there's again the question: how narrow do you want your theory to be valid? Maybe you can find a stronger theory if you restrict the forms of problems. Yeah, as I said, time to find a pattern might be important there, and not just time to solve like the brute forcing problem. So it's probably not just solved by compute, although compute might be a super crucial ingredient. Maybe we have already found the architectures where you just need to more compute and then you get to all intelligence levels. I don't know, nobody knows. Yeah, so I suppose research in the models, which indeed, like all the PyTorch experimentation and so on, is really not just happening in universities, but I suppose this is sort of, I guess the people do try to find out how far can you get with that, right? So maybe it's not a formalized theory, sadly, and maybe one can work with those people, but yeah, there's certainly work done, I guess. Yeah, and then one last comment there is it really just about intelligence to find a proof of the mathematical theorem, or as is the case in, if you compare it to what Wiles did, should there be some side output that enables other people to learn new things, right? Because the academic research is in like the way math is developed, also leaves breadcrumbs and leaves new questions on the side and so on and so forth. Do we, by intelligence, just understand something that solves a problem that could also be solved with brute force, but instead finds the better way, but still is only concerned with the problem? Or is there supposed to be an output? Should this thing be more human? I don't know. This, of course, always raises the question: is the human maybe not also just an automaton, and all the side effects are just incidental? But what I'm just saying is that there's more to prove than just going from the question to the result. There's also the beneficial side output. Should any of those be part of the quantification of intelligence, right? I'm basically saying that is intelligence, do you want to really just use the word for finding solutions for problems, or is there I'm not sure if I want to say community aspects to it, and so on. On a related note, coming back to the classification of problems like with the arithmetic hierarchy and so on that is actually done, and where there is sort of a subject which is concerned with that, and not just in arithmetic, but in set theory it's called Levi hierarchy, which classifies sort of statements and problems by syntactic properties, and a descriptive set theory and whatnot. Could it not be that that what we understand as intelligence is like, do we think that there's an intelligence general enough so that we have one systematic way of assigning numbers to the intelligence, or do we allow to restrict the kind of problems? What I'm thinking about is that imagine in some other, Alpha Centauri, there's some being which is some gaseous being or some silicon-based life form, and their like problems, like they are like physically so different that their problems are really also like extremely different from ours. We can, they are like gas bodies. Maybe they're thinking beings, but they're like 2 kilometers wide, and they have a completely different conception. But presumably, Church thesis is true, and computation is still the same that we do. Their numbers, the integers and so on, are the same, and recursion exactly works. So they have the same sort of computation. They have the same tools to compute. And if they build an AI, then they also can, like, even if it's implemented differently with different material, it's still essentially just what is expressed in arithmetic with piano arithmetic, recursion theory, and so on and so forth. But this sort of system, they would solve with the same tools completely different problems. And let's say that is the case. There is some other species that has completely different problems that we don't even think of solving and that we don't optimize for. If we make a general theory of intelligence, then it might, even if we don't know about this species, it might then also, like, it might lack because the theory tries to incorporate also this completely different theory. So maybe it is necessary to restrict, like somehow formally restrict the type of problems to earthly problems to get a good answer that has any value for earthly scenarios, right? You want the theory to quantify intelligence, maybe to predict how quickly on Earth the AIs will develop and whatnot, whatever your application goal is. You can also elaborate on that. But maybe we have to pin down the sort of problems we address, because there might be completely different classes of problems that are so remote from each other and not of interest of us that we would actually want to rule them out. Otherwise, maybe we're lacking a good theory because we're going too broad, right? I brought this up a couple of times now. Okay, I'm at 1 hour. I hope this was helpful. I know it was very ranty, also for any other viewers of this channel. It's much more like general than my usual physics talks on, but nevertheless, interesting discussion for sure. And I would like to hear back from you. Take care.